This video lesson will focus on ions and drawing Bohr-Rutherford diagrams for the first 20 ions. You're also going to be able to name the ions and then indicate which noble gas has the same electron arrangement as the ion that you drew. This is the Bohr-Rutherford diagram for a sodium atom. The number of protons is equal to the number of electrons. Now the electrons, again, are in these fixed energy shells. The first one can hold 2 electrons, the next one can hold 8, and the next one can hold 8. But in this case, we only needed to accommodate 11 electrons. Now to find the proton number and the electron number for a neutral atom, we look at the periodic table and look at the atomic number. For sodium, the atomic number is 11. So that's the number of protons, and that's the number of electrons. They're equal, which creates a neutral atom. Now, sodium is a metal, and it is unstable. It has this one electron in its outer shell, and it would like to lose that electron. We're going to worry about where it goes later, but it wants to lose that electron to become stable. Then the shell below will be full, and we call that a full octet, and now it is a stable atom. Because it's lost an electron from its outer shell, the number of electrons is going to be less than the number of protons. So let's draw the Bohr-Rutherford diagram for the sodium ion. So the nucleus remains the same, so we still have 11 protons and 12 neutrons in the nucleus of the atom. It's the electrons that are either being gained or lost to form ions. So the first shell still has the 2, those were not touched. The next shell is now going to have 8. So this atom is now going to have a total of 10 electrons. Now because it has less electrons than protons, it's an ion, we're going to draw brackets around it. And because it's lost electrons, it's lost negative charge, it forms a positive ion. Now because it only lost 1, we don't have to write the 1. So this forms a sodium ion. We're going to write the symbol and then the charge. To name this, we just call it sodium ion. Now metals form positive ions because they lose electrons to become stable. Positive ions are also called cations. Now these are Bohr-Rutherford diagrams for a neutral sodium atom, so the number of protons is equal to the number of electrons. This is for a sodium ion. The number of protons does not equal the number of electrons, and in this case the outer shell is full and stable. Now this ion, because it's stable, it's going to look like a noble gas's electron arrangement. And that's because noble gases have stable electron arrangements because they have full outer shells. So what does this Bohr-Rutherford diagram look like? It looks like its closest noble gas, if you count down, which is neon. This is a sulfur atom. It has 16 protons. I'm getting this from the atomic number. It also has 16 neutrons, and it has 16 electrons. Now, in the outer shell, there are 6 electrons. It's unstable. It wants to have a full outer shell. It wants 8. So what it's going to do is it's going to gain 2. We're not going to worry about where they're coming from at this point. We're just going to consider that it wants to become an ion, and it's going to form a negative ion. So we're going to draw the Bohr-Rutherford diagram for the ion that gets created using sulfur. Now the nucleus is the same. Okay, the first shell is also going to be the same. It still holds 2 electrons. The next shell is also going to be the same. It's going to hold 8. And then the third shell is now going to become full. Okay, it had 6, but now we're going to add 2 to make it have 8 and therefore have a full outer shell. We're not going to worry about where the electrons came from, nor do we have to draw them any different to show that they've been gained. Okay, so now it has a full outer shell. It's now an ion because the number of protons and electrons are not going to be equal. We're going to draw it in brackets, and we're going to say that it's gained 2 electrons. Because it's gained electrons, it's now a negative ion. And if you count, the number of protons, 16, but the number of electrons is 18. So it actually has 2 more electrons, giving it that 2 minus charge. Now the symbol is going to be sulfur, then it's going to be a 2 minus. Okay, the name of this is, we use the stem of the original atom's name, but we change the ending to "ide." So this is called a sulfide. So it's a sulfide ion. Now this is a nonmetal. Nonmetals gain electrons to become stable. They form negative ions. We also call negative ions anions. Just leave it as a, we won't pluralize it. So this is the Bohr-Rutherford diagram for the sulfide atom that was on the last screen. Now this, because it's become stable, it's gained electrons to become stable and have a full outer shell, it's going to have the same electron configuration as the closest noble gas. So for nonmetals, you work your way up the periodic table. So in this case, sulfur is number 16. It's going to work its way across the periodic table and to the closest noble gas, which is argon. Now, noble gases do not form ions because they already have full outer shells. So let's draw the Bohr-Rutherford diagram for argon. So the Bohr-Rutherford diagram for the argon noble gas is right here. Again, it's number 18, so that's the number of protons. It's also the number of electrons. This is neutral because the electron number and proton number is equal. Now this is the same electron arrangement as the sulfide ion. So the sulfide ion is trying to have the same electron arrangement as the closest noble gas. And in this case, it's argon.